Okay. Uh, Good morning, everybody. My name is Ephraim Tadessa. I'm lecturer at Jama University, Faculty of Computing and Informatics. My research interest falls into the intersection of natural language processing and data science. Particularly, I'm interested on information extraction tasks and machine translation, and also time series data analysis and modeling. Today, I'd like to present about natural language interface for COVID-19 Amharic database using LSTM long short-term memory encoder-decoder architecture with augmented attention. So, as most of us we know, COVID-19 disease is a contagious virus caused by SARS-2, usually called severe acute respiratory syndrome 2, and COVID becomes a global health crisis which causes human life um, and still promise to create ripples of death and destruction. Uh, Mainly, COVID has become a challenge for the developing countries because as the pandemic begins, there was no any source of reliable information, and this lack of up-to-date information uh, causes a lot of anxiety and has become a challenge to uh, you know uh, prevent the pandemic because of lack of up-to-date information for the people, fundamentally using even international languages. There was a very few um, reliable source of information like WHO um, and other stakeholders. Um, so, as a problem definition, during the pandemic in Ethiopia, there was very few initiatives like RP, which is Emergency Response Project, which was initiated by MOH, Ministry of Health, and uh, Ethiopian Public Health Institute, which is EPHI. This project was aimed to monitor the prevention mechanism, screening, testing, and then daily reports of like days, new cases, and others too. By organizing task forces, local task forces. At the time, there wasn't any digital platform except the mainstream medias. Later on, there was very few attempts just developing mobile apps, simple mobile app to disseminate information. For instance, Ethiopian Community Health Information System, which is CHIS. It is also initiated by MOH. Overall, there was just lack of consistent information, and this leads people possibly harms the prevention effort and increase anxieties. So, having said this, as a motivation, most of the information flows like symptoms, prevention, transmission, and reporters was constantly changing, and there was no reliable source of information using any of the local languages like Amharic. Following this, recently, NLP advances to uh, be applicable in various sectors like healthcare, using precise information um, for users utilizing uh, clinical evidences. Um, I mean, clinical notice as an evidence, for instance, like clinical decision support system and others. So, using this advantage, uh, there's also a natural language interface which allows users to interact using written or spoken human commands instead of computer language. So when we say NLI, so people could have possibility to ask any natural language utterance or questions. Unlike the experts or computer professionals, it is tough for the novice users to manipulate structured query language. So basically, I could say it's impossible for the novice users to ask or query information from the database using bulky SQL commands. In this regard, NLI solves this problem, especially for the companies, commercial companies, healthcare industries, and agricultural sectors, developing a natural language question translation system into the parallel query, and then fetching a relevant source of information from the database and populate for the user. So it's all about NLI. Um, there was very few attempts on this particular task. Natural language interface tasks. Uh, the one which was proposed by Zung use used sequence to SQL model, which is a deep neural network for translating natural language question to corresponding SQL queries. So basically, they have used an LSTM based model to translate question to parallel SQL queries. Another work which was conducted by Semenyo, they proposed a concept-based pattern matching and role-based approach for Amharic language interface. This paper mainly focused on pattern matching. We could say total heuristic based approach to develop question to SQL model. So this was a prominent attempt for Amharic so far. Uh, Another work also proposed uh, which utilizes the semantical feature aware encoder-decoder framework to translate natural language trends to database queries. The authors in this paper has used semantical features. When we say semantical feature, it's just pre-trained word embedding and basically embedding of those questions. So they say like semantical features aware encoder-decoder framework to translate the natural language question to the corresponding queries. So having this in mind, we came up with an NLI system for COVID-19 information. So, as just a pipeline of methodology, initially we have extracted COVID-19 related information from various relevant sources, as I mentioned earlier, such as like WHO and John John Pekin. University. Um, Following this, we have constructed a database to demonstrate the proposed model, and then we build a model that translates this Amharic COVID-19 Amharic question to corresponding parallel SQL query using attention augmented encoder-decoder LSTM network. Finally, we have developed a demo which utilizes the trained model just to enable users to ask questions using natural language interface, natural language question, and then translate to the corresponding query and return back COVID-related information, prominently like symptoms, prevention, and then other details of COVID-19. Good. So as a preliminary step, we have constructed simple question SQL parallel dataset. Just as I mentioned earlier, source of information was WHO and MOH and other credible sources to extract contents of this information to construct our database and to construct our parallel dataset. So this was not basically an easy task, so which was like around 2,600 instances parallel SQL, I mean question SQL instances or question and SQL corresponding pairs. So the prominent information incorporated in the dataset as a question and a query are like symptoms, transmission, and prevention. So, in addition, like frequently asked question and daily clinical reports in case of Ethiopia. Why we focus on symptoms, transmission, and prevention is just fundamentally because of people worry about how to prevent, how COVID-19 transmit, and then what are the important symptoms of the pandemic by the time. So we just constructed sorts of questions and parallel queries on those important concepts. So good. So let me proceed to the method we have employed. So basically, in encoder-decoder architecture, the simple strategy is just for general sequence learning. We map the input sequence to fixed child vector using single RNN unit, and then following this, we map the vector to the target sequence with another RNN unit. So in this case, we have a hidden state H and an optional output sequence Y, let's say Y. So to compute the hidden state, we'll operate on the variable length sequence X at time step T. And yeah, basically we could have like just compute previous hidden state and variable length input sequence, let's say X. So we can apply the activation function, which is a linear hyperbolic tangent function, or tan, usually said. So we'll calculate this hidden state by using the weight at previous hidden state plus the weight at a current input state. And then we could apply the tangent function. So basically, simple RNN was not sufficient. Is not sufficient to compute sequence to sequence model because of the variation of lengths in the input sequence and the corresponding output sequence. To do so, we came up with the LSTM network, so which is better in long-term dependencies on the encoder. Single RNA units. So this addresses the vanishing gradient problem of RNN, which is basically criticized for its limitation to handle the long-range temporal dependencies. So in case of LSTM, we just calculate the probability distribution this of the input sequence. The target sequence based on the input sequence. This could be computed using the conditional probability by obtaining fixed dimensional representation V on the input sequence, let's say X. X. So this can be computed using the probability of the target sequence Y with the standard LSTM language modeling formulation, was initial hidden state is set to the representation V of the input sequence. Basically, this was still has critical problems. So the challenge in terms of this encoder-decoder architecture is which forces to compress all input sequence. When I say like input sequence, just each independence instances, in our case questions. So this will compress all input sequence to fixed length internal representation. In this case, this constrains the performance of the network for long range sequences. So an attention mechanism solves these constraints. This allows to pay attention in the input sequence for each item in the output sequence. So in our study, we have employed Badano's local attention. Basically, Badano has came up with the first attention model in 2015, which was similarly used in neural machine translation based encoder-decoder LSTM network. So this was a very elegant and simple idea. So Badano's attention mechanism, what it does, so basically the LSTM process the entire input sequence into and encode into a context vector. We could say like the last hidden state of the LSTM or RNN unit. So the attention mechanism basically focus on just not all input sequences can be taken into account during constructing the context vector. However, we'll focus on relative importances to each of them. So as the name indicates, we'll focus on the relative importance of each input sequence. So to do so, we'll have like the context vector can be computed using the weighted sum of annotations of each input sequence, where the input the weighted sum can be computed using the softmax activation function. So indeed, when you embed all input sequences into inputs, or we could say like hidden status, and then we'll create the context vector. Basically, the context vector can be created by taking the weighted sum of these hidden status. So here you have like input sequence. We in our case the natural language transfer questions, and then we'll have annotation of those particular input sequence. We'll have attention weights for each sequences, and we'll calculate the context vector, and then we'll map to the corresponding SQL queries. So just to talk a bit on the parameter tuning and configuration for the LSTM network with augmented attention. Basically, we have used various parameter values. Just to talk a bit on some of the values used. So like the latent dimension is 64, and our input source, maximum input source is like 67, and we have used categorical cross entropy, it's loss function, and the matrix is accuracy. We have used Adam optimizer, and we have already basically tested various batch size and iteration values or epochs, and a minimal learning rate which is 0.001 and dropout of 0.2. Basically, we have also used the callback and early stopping mechanism to avoid overfitting, just using asymmetrics, the validation loss. So here you go, as you can see from the graph. So training and validation loss decreases from the initial value as the iteration rate increases and gets closer to the actual training loss value to stop the training. All right, so just we do have this evaluation. We have used the build score and accuracy evaluation metrics. Just we have evaluated independent LSTM network and LSTM with help of attention. So far we got good accuracy when we augment custom attention on the top of the LSTM encoder decoder architecture, as you can see here from the table. So just to talk a bit on how the NLI works, as you can see here, the user enters COVID-19 related user question, which is natural language question, and at the back, this question has to be translated to the parallel SQL query, and will fetch data from the database, and the user will get in touch with the COVID-19 related information. So here most of the steps will be done at the back. Just this is how the user interacts with the proposed system. So we have tried to develop an interface to utilize the model. So as you can see here, the user can put a question and then ask any question. We have prominently focused on symptoms prevention and transmissions. So here you go. Just as a way forward and conclusion, we have used attention augmented LSTM network to develop Amharic COVID-19 related question to parallel SQL query translation model basically, and we have constructed a database to evaluate this model. In addition, we have constructed also a simple size parallel data set. It could be just an initial step for the coming researchers. Still we got a promising result, and as a recommendation, it would be nice to develop large scale parallel SQL dataset to scale, or just to reproduce this paper. And moreover, it would be nice also to enable a voice for the that address the challenge for maybe disabled people. So thank you. This is my presentation.